So you're asked to solve an equation like this, and just as important as the equation itself is the interval. Step one is to state and then make the substitutions. And the substitution is simply what is in the bracket of the trigonometric function. I've deliberately used the plural here. Don't forget you've got to make the substitution into your interval too. Now the smallest value that theta takes is minus 20 degrees. So 3 times minus 20 add 45 gives us minus 15 degrees. And similarly, the largest value that theta takes is 160 degrees. So again, 3 times this, add 45 degrees, gives us 525 degrees. And here we have our much simpler equation to solve. Step 2 is just what you're used to. Use your calculator to solve this simple equation and find the principal angle. Step 3 is to find the partner angle using symmetrical properties of the trigonometric function being used. Now in the case of sine, this is 180 degrees minus the calculator angle. Now if this had been a cosine function, the partner angle would have been minus 30 degrees because we simply changed the sign of the calculator angle. And if it had been a tan function, we wouldn't even attempt to find a partner angle. This is a step that we skip. Step 4 is to use the cyclical properties of the trigonometric function in question. We know that the sine and the cosine functions repeat every 360 degrees, so solutions will repeat every 360 degrees. In the case of tan, however, solutions repeat every 180 degrees. But since this is sine, we'll add and subtract multiples of 360 degrees to both the calculator angle and the partner angle until we're sure we've covered the interval that we're given. So I'm going to add 360 to 30 degrees. There's no point in me adding another 360 degrees because I can see that's going to take me beyond the interval. But I'm going to subtract 360 degrees as well just to be sure, and I get minus 330 degrees. I'll now turn my attention to the partner angle, and similarly I'll add 360 degrees. And again, I won't add another 360 degrees because I can clearly see that again will take me beyond the interval. But just to be safe, I'm going to subtract 360 degrees. And that gives me minus 210 degrees. Now I'm sure I've covered this interval here, and in fact I've erred, as you can see on the side of caution. So there are some calculations or solutions, I should say, that I can discard because they fall outside of this interval, and in particular minus 330 degrees and minus 210 degrees can be discarded. Finally, in step 5, I'll reverse the substitution and change my answer from being in terms of x back to being in terms of theta. I can see that the reverse of the substitution I made is I take x, subtract 45 degrees from it and divide by 3, and I'll carry this process out to each of my solutions here, giving me these answers. You can always check these, of course, by substituting them back into the original equation and checking that the left-hand side is equal to the right-hand side. And reassuringly, these all fall within the interval of the original equation. So lastly, here's the full list of steps we carry out.